it's that time, so we're going to go ahead and get rolling. Today we are finishing up Unit 3. So, Wednesday, Unit 3 test. I will still be on the network. I'll leave it up to your location whether you want to log in or if you just want to take the test in your room. I will be here, so if there's any questions that you want clarified, it'd probably be to your benefit to be logged in, but you certainly don't have to for the test. As always, you do have extra time for the test, even though we're only going to take one class period. If you need more time beyond that, please arrange it at your site and finish that up. All I ask is that they be finished within 1 week, that I have them back by April 13th. So hopefully at the end of class today, we'll have just a few minutes just to go over the topics, because it has been with spring breaks and everything, it has been a little spread out, so we'll take some time to at least list out all the different topics that will be on that. So anyway, today's topic, to finish off the unit, we want to talk about safe dosage. And what really is going on here is we're dealing with a doctor's order for a dosage, but being the person administering the dosage, even though that's already been determined by someone else, you are still responsible for verifying that that is within normal parameters and it's a safe dosage for the patient. I'm kind of thinking of it as the last line of defense. You are the last person that has the ability to stop that dosage if it goes against recommended safe guidelines for that medication. So our first example is we're going to have a doctor's order, 40 milliliters, be administered every 6 hours. And we look at our label of our supply, and on that label it says 6 to 8 milligrams per kilogram every 8 hours. And we have a patient (77 pounds). And also on the label, it is concentrated at 25 milligrams in 4 milliliters. So, again, this is going to be a dosage based on weight. Now, one of the things you'll notice might be different is the doctor's order is actually already spelled out, 40 milliliters every 6 hours. Even though they've already spelled that out, rather than just administering that medication, as I said, it is up to you as the person who might be giving it to the patient to verify that that is a safe dose. So we will ignore the doctor's orders and totally calculate this ourselves and then compare it to the doctor's order later. Start off with our patient who is 77 pounds. We're going to divide by 2.2 to convert that into kilograms, giving us 35 kilograms for our patient. So that's the number we will use to start our calculation for our safe dosage. 35 kilograms, we're going to put that over 1 to make it a fraction. We need to get rid of the kilograms on bottom. And as usual, we're going to use the maximum end of the range of our dosage, 8 milligrams per kilogram. So the kilograms have canceled out. And remember, we're going to come back to that time frame of per 8 hours later. Now we need to get rid of the milligrams. Down here we have 25 milligrams and 4 milliliters. So I'll put the milligrams on bottom. Out. Now the only units we have left are milliliters, which is what we want. So let's go ahead and multiply out here. We have 35 times 8 times 4. Here's 1,120 milliliters. On bottom, 1 times 1 times 25 is 25. So we'll divide that up. 1120 divided by 25, we have 44.8 milliliters. That's a maximum dosage, and at first glance, that looks like that might be safe because the doctor's ordered 40 milliliters, but this time frame is per 8 hours. Doctor has ordered the dosage to be administered every 6 hours. So we need to make now an adjustment, a titration, to adjust this as an 8-hour dose to a 6-hour dose so that we can accurately compare to the doctor's order. 44.8 milliliters. That's calculated on 8 hours. We're going to switch it to a 6-hour dose. The hours cancel out. 44.8 times 6 divided by 8 gives us 33.6. That is milliliters every 6 hours. So right away, we notice that the doctor's order exceeds maximum recommended dose. Excuse me. Let's go ahead and complete the calculation to find the complete range. This is the maximum dose. Let's find the minimum so we can establish what the recommended range is so we can present that then to the doctor for possible adjustment of that dosage. So we have the 33.6 milliliters every 6 hours. That was figured off with the maximum recommendation of 8 milligrams per kilogram. And we want to titrate it to see what it would be for 6 milligrams per kilogram. So 33.6 times 6 divided by 8, 25.2 milliliters every 6 hours. That is the minimum dose. So for this patient, the recommended dose, 25.2 and 33.6 milliliters every 6 hours. So the doctor's order was outside of the recommended range. A couple of things here. First, this does not mean you just change the dosage and give the recommended dose. You still have to go to the doctor and have the order changed because there is a small chance that there was some reason unknown to you that the doctor wanted that extra dose put in there. There in some cases are reasons where you can give larger than the recommended dose as a medically necessary treatment. Second, I want to be careful not to say that the doctor here was wrong. The doctor may or may not have miscalculated. Often what happens, and this happens more often than you would think, that the doctor's dosage is incorrect for the patient for a couple of reasons. Here, the patient coming in pounds, the doctor can often miscalculate that conversion. Rather than punching it in, can just try to do a quick mental calculation and make it wrong. But often what it is a possible change in supply. It's very possible that the last time the doctor ordered this medication, it might have been 15 milligrams and 4 milliliters, which would have been a very different concentration, would have given us a very different resulting number. Quite a bit higher number of milliliters because we have lower concentration of medication. So there are a lot of reasons why the doctor's order might not be correct, and not necessarily a mistake or a fault of the doctor. It could have been that when this order was given for the patient, the supply might have been different, and that bottle is emptied, and we have a new bottle, and it has a different concentration. So there's a lot of things that can happen there. Or it could have just been the doctor's oversight and recommended it every 6 hours when they meant to say every 8 hours. A lot of reasons why that dosage can be off. And like I said, happens way more often than you would like to think. I'm obviously a little bit of a numbers cruncher, statistics. One of the statistics I saw was about 1 in 6 medications administered, or 1 in 6 patients who stay in a hospital more than 2 nights are administered an incorrect medication or incorrect dosage of their medication at some point during their hospital stay. So it is very common, and it is very necessary to make sure those dosages. So let's take a look at the next example. Our order here is for 5 milliliters twice a day. Label, 250, 300 micrograms per kilogram per hour with a concentration of 5 milligrams and 2 milliliters. And our patient is 88 pounds. So as always, our first task is going to be convert that pounds into kilograms. 88 pounds divided by 2.2 should give us 40 kilograms. That's where we start off with our calculation, 40 kilograms. We have 300 micrograms per kilogram. I'll cancel out the kilograms. Now we're in micrograms. This next level on the bottle is in milligrams, so we do have to make that conversion. That's a standard conversion, so we don't need any label equivalency. We know that 1,000 micrograms equals 1 milligram. Now we're in milligrams, so we can use that next conversion. 5 milligrams into milliliters. Milligrams are gone. We're in milliliters, which is what we want, so that we can compare to the doctor's order. So on top, we have 4 times 300 times 2 milliliters. 40 times 300 times 2 milliliters. 24,000 milliliters. Over 1 times 1,000 times 5 is 5,000. Divide that out. Giving us 4.8 milliliters. Now again, we have to bring our time frame back into this. This is per hour. So this is per hour. This is saying twice a day, 5 milliliters twice a day. That's every 12 hours. So I'm going to titrate my 4.8 milliliters. That is per 1 hour. We want to take it per 12 hours. Hours cancel out. 4.8 times 12 divided by 1. Of course, is going to give us 57.6 milliliters. That's every 12 hours. That's our max dose. To get our minimum, doctor's order definitely has not gone over the max. Get our minimum, $57.6 milliliters every 12 hours. That was calculated on 300 micrograms per kilogram. For that 250 micrograms per kilogram. Micrograms per kilogram cancel out. 7.6 times 250 divided by 300. 48 milligrams every 12 hours. So So here we have the recommended range, 48 to 57.6 milliliters every 12 hours. Doctor's order was 5 milliliters twice a day, or 5 milliliters every 12 hours. So again, this would be a case where the doctor's order is not too large, it's not harmful, but it might not be large enough to be effective. It's well below the recommended limits. So you'd want to consult the doctor and confirm that really is the intended dose. Let's take a look at a dosage that's an IV, intravenous. Doctor orders bag of medication to be hung and infused at 20 drops per minute. Patient label on our supply says 8 to 10 milligrams per kilogram per hour. The medication concentrated at 25 milligrams in 8 milliliters. And a drop factor of 12 drops per milliliter. So again, the doctor's order is already set up. It's a ready-to-go order. You just would have to set up the IV to make that. But again, we want to go through the calculation just to confirm the doctor's order. So as always, we're going to start out with the patient. Pounds, we're going to divide by 2.2. Take that, I believe that's 30 kilograms. It is. And so 30 kilograms is where we start our calculation. We'll put kilograms on bottom here. Again, we'll use the maximum range, 10 milligrams per kilogram. Get rid of kilograms, let's get rid of milligrams. We have 25 milligrams in 8 milliliters. Get rid of milligrams. Now we need to get rid of the milliliters. Drop factor, 12 drops per 1 milliliter. And now we should be in drops per hour. So we'll make that conversion necessary. We'll bring in the hours in just a little bit. Let's go ahead and calculate through here. 30 times 10 times 8 times 12 is 28,800 drops. On bottom we have 25 divided by 25. So 1,152 drops. And now we bring in the time, which is per hour. So we'll need to adjust this now to be per minute. 1,152 drops per 1 hour. Conversion. Hour is 60 minutes. Hours cancel out. We got 1,152 drops. 60 minutes. We divide that out. 1152 divided by 60. 19.2 drops. That is the upper end. Let's titrate it now. The doctor's order is 20 drops per minute. Just outside the edge of this range. But let's find the rest of the range just to see how out of line it is. 19.2 drops per minute. That was calculated off of 10 milligrams per kilogram. We want to titrate that to the 8 milligrams per kilogram. 19.2 times 8 divided by 10. 15.36 drops per minute. So in this case, the recommended range, 15.36, 19.2 drops per minute. The doctor's order of 20 drops per minute here is slightly outside that range. But you see, that's a range. It's almost 4 units wide, being 0.8 units out. A little far. It'd be one to double check, but it's very possible that it's just a rounding thing. The doctor rounded the dosage up, where it's still a very appropriate dose. But again, that would be one to double check because it is slightly outside of that calculated range. We have a doctor that orders 2 milliliters to be administered every course. For a patient, £70 and 47 tall. Table is recommended of 7 to 8 milligrams per meter squared per day. Concentrated in 5 milligrams, 4 milliliters. So our first item to do here, this is obviously a body surface area problem because we're looking at meters squared here. Also being given both the weight and the height. There's a tip off there. We're looking for a body surface area in meters squared. It'll be the square root of the height times the weight. Since those are in inches and pounds, it's divided by 3,131. Square root of 47 times 70 divided by 1. Close that parentheses. 1.03 meters squared. It's our body surface area. So we start with 1.03 meters squared times, again we use the maximum, 8 milligrams per 1 meter squared. Meter squared cancels out. We need to get to the next step then would be from milligrams to milliliters. Milligrams are going to go on bottom to cancel out, so 5 milligrams in 4 milliliters. Milligrams cancel out, and let's see what that gives us. 1.03 times 8 per 0.96 milliliters. 1 times 1 times 5 is 5. So we divide by 5. 6.59 milliliters. That is per day. We got to bring in that time frame. Doctor ordered it every 8 hours. Titration, 6.59 milliliters. We have to do conversion. A day is 24 hours. It'll be per 8 hours. The hours cancel out. We take our 6.59 times 8 divided by 24. 2.20 basically. Milliliters every 8 hours. That is the max dose. Find the minimum. We titrate that, 2.20 milliliters. We're titrating off of, that was figured off 8 milligrams per meter squared. And we want to titrate that to 6 milligrams per meter squared. And so the milligrams per meter squared cancel out. We'll take our 2.20 times 7 divided by 8. Gives us 1.93 milliliters every 8 hours. So our safe range here, recommended range, 1.93 to 2.20 milliliters every 8 hours. The doctor's order here of 2 milliliters every 8 hours is obviously right down the money. We're right in line with that. So that's a good, safe dose. So we've confirmed that dose. We can go ahead and administer it. We don't have anything else to double check. Something I should note here. The recommendation in this one was per day, and the doctor had to administer it every 8 hours. That is generally okay to go with a smaller dose more often. Some of the ones we've seen have been, like the second example was per hour, and the doctor ordered it administered twice a day. That can be an issue because we're going to a larger dose, less frequency. That one single large dose might be too much at a single time. So if we're going from a large period of time to a smaller period of time, that's usually okay. Going the other direction is something totally separate that may have to be double checked. The size of the dose might not be an issue, but the frequency, giving the larger dose less frequently might cause damage than giving the small dose more frequently. So something to be aware of there, even though mathematically it might be in the correct range, it might still be a hazardous dosage for that patient. Okay, so let's do a couple more examples here. In fact, I'm going to let you guys try one in your notes here to see. Doctor here has ordered 50 milliliters to be administered every 8 hours for a patient that is 110 pounds. Look at the supply, and the label on our supply says recommended 8 to 10 milligrams per kilogram, 6 hours, and it is concentrated at 15 milligrams in 4 milliliters. So I'm going to give you about a minute and a half. Try this one in your notes. See if the doctor's order falls in the safe range for that medication. Once again, our first step is going to be to convert that weight in pounds to kilograms. We divide 110 pounds by 2.2 to get 50 kilograms. Now, of course, we do the high end of the recommendation is 10 milligrams per kilogram. Canceling out the kilograms. And next we have 50 milligrams and 4 milliliters. So the milligrams go on bottom to cancel those out. We're now in milliliters, which is what the doctor's order is in. So we're going to do the 50, 10 times 4. 1,000 milliliters over 50. We divide that out, that is 40 milliliters. Now this looks like it could be an issue, but then we still have to bring in the time, which is the 6 hours. That's 40 milliliters every 6 hours. Titrate that in the doctor's orders every 8 hours. 40 milliliters, that's figured on 6 hours. We need to go to 8 hours. Hours cancel out. 40 times 8 divided by 6. 53.33 milliliters every 8 hours. Find the minimum at 53.33 milliliters every 8 hours. That was calculated off of 10 milligrams per kilogram. And we want to titrate it to the minimum, which is the 8 milligrams per kilogram. .33 times 8 divided by 10 gives us 42.67 milliliters every 8 hours. So our recommended range here is 42.67, 53.33 milliliters every 8 hours. Now, as we noted here, we should still, even though the doctor's dosage, the 50 milliliters, is in that range, it's right in the middle of that range. Because the recommendation was every 6 hours and the doctor ordered every 8 hours, you should still maybe double check with the doctor to make sure that the less frequent, the larger dose less frequently is not an issue. If we have time, we might still come back and do another example or two of these safe dose calculations. But before we run out of time, I want to make sure we at least give you a list of topics, because with spring break and everything, this unit is kind of dragged out a little bit time-wise. Remember, we started out with titrations, or not titrations, with dilutions, I should say. Remember, a dilution, a 1 in 6 dilution, means 1 part serum, 6 parts total solution. So if I give you that we have a 2 in 7 dilution, and I ask for the ratio from the saline, two to 7 is the dilution. 2 is the serum. 7 is the total solution, not the saline. Get it as serum to water or serum to NS. It's still 2 parts of serum, but it's the 7 total parts minus the 2 parts serum gives us 5 parts of saline or NS. That becomes a 2 to 5 ratio of serum to saline. So we have to make that adjustment. Other things we looked at were adjusting the concentration of a solution. So let's say we have a 36% solution is diluted 4 and 9. Find the new concentration. Well, here we simply just take our 36%, not 34%, 36%, and we use the 4 and 9 dilution. A 4 to 9 dilution, the new concentration will be smaller, so that the new concentration will go with the 4. The 9 goes with the 36. We just cross multiply and divide. 4 times 36 divided by 9 gives us 16%. So that diluted solution will be 16% concentration. Okay, so next then we had a change of concentration, or sometimes called the concentration adjustment. That was V1 times V1 times V2. So if we have 400 milliliters of 18% solution diluted 1,000 milliliters, find the new concentration. We started out with 18% times 400 milliliters equals our new concentration times 1,000. Multiply the 18 times 400, 7,200. 1,000, we divide by 1,000 to get our concentration. 7.2%, that new concentration. Excuse me. And then, of course, we've looked at all of our different dosage calculations that we've seen here in the last couple of weeks. Dosages based on weight, the body surface area, IVs, all of that. One calculation from way back at the beginning of the unit that I want to show you is, let's say that we have a patient whose numbers exceed the capability of our meter. So we dilute 400 micrograms of blood with 200 micrograms of sterile water. Meter then reads 723 milligrams per deciliter. Find the true reading. So the first thing we need to find is the dilution performed here. Dilution performed is we had 400 micrograms of blood diluted with 200 micrograms of saline. Now remember, a dilution is serum, which is the blood, to total. So on bottom here, it's not just the 200, it is the 200 plus the 400 micrograms of blood to get a total volume. This is 400 micrograms, 600 micrograms. Of course, the micrograms cancel out, and that gives us a 2 to 3 dilution, or a 2 in 3 dilution. That dilution then is used to adjust the reading of 723. 2 to 3. The 723 is the diluted reading, so it matches up with the smaller number, which will be the 2. And we'll cross multiply and divide. 3 times 723 divided by 2. times 723 is 1,084.5. So that reading is 1,000. The true level of that person's blood is 1,084.5 milligrams per deciliter. Non-diluted levels. Let's do one more example here before we call it. So our order is for 3 milliliters administered every 6 hours. Our label, 12 to 15 milligrams per meter squared every 8 hours. Concentration of 30 milligrams, 4 milliliters. Patient, 120 pounds and 5 inches. So first we're going to do the body surface area, height times weight, over, since that is pounds and inches, it will once again be over 3,131. Calculate that out. Calculate that out, we get 5 times 120 divided by 31. I'm not going to square right yet. 1.58 meters squared. That's where we start our calculation. So we have, we'll use the maximum number again, 15 milligrams per square meter on 30 milligrams in 4 milliliters. Milligrams are gone. Let's calculate that out. 1.58 times 15 times 4, 94.8 over 30. So divide that out. 3.16. Doctor's order looks fine so far, but then we bring in our time. That is for 8 hours. Doctor's order was every 6 hours, so we have to perform that adjustment. Changing that 3.16 milliliters from being 8 hours to being 6 hours. Hours cancel out. 3.16 times 6 divided by 8 gives us 2.37 milliliters every 6 hours. That is the maximum, which appears the doctor has gone over. Now let's get the full out range just to be thorough. 0.37 milliliters every 6 hours. That was calculated off the minimum, or sorry, the maximum of 15 milligrams per meter squared. Minimum would be 12 milligrams per meter squared. 0.37 times 12 divided by 15. We'll round that to 1.90 milliliters over 6 hours. So our recommended range here is 1.9.37 milliliters every 6 hours. I think that's enough for today. There is no new homework. Everything for this chapter has been assigned. Make sure you go back through and review. Like I said, this is the test that is really the nuts and bolts of the class. This is the important material. This is also the test where grades tend to dip a little bit because this is stuff you haven't seen before. So please make sure to look over this unit a little bit between now and Wednesday. With that, you guys have a great day, and hopefully we'll see you all back on Wednesday. Excuse me.